Good afternoon, everyone, and welcome back to the afternoon session of Stir Trek. Hope everybody had a decent lunch. What did you think about the videos? They were videos? I'd like to get started with Adam Pasternack. I am informed that he is a culinary artist from Improving and also a big fan of Ohio. So if you would.
Welcome. Thanks everyone for coming out. It's going to be a good day. I just wanted to first, it's after lunch, we're all a little sleepy. Let's give a big round of applause for all the volunteers who made this possible. I know personally some people have been here since 6 a.m., so very thankful for them for making this day happen. So today I'd like to just share with you some of what I've learned about Angular from working on 2 large projects. So what I want to start out with is really a dissection of the ending of Affinity Wars. I really wanted to, no, I'm just kidding. No, at work, I've been avoiding this for a week now that they bumped the movie up. I'm like, don't tell me anything. I'm going to see it tonight. Just kidding. That would be the worst ever. What I really want to talk about is using Angular with the Redux pattern, and the most popular implementation of that is a library called Ngrx. A little bit about me. My name's Adam Pasternack. I've worked at a few different companies in town. Here's some of the companies I've worked on, projects on. I'm currently a consulting for Improving, and I work at Wendy's 90 Degree Labs. I see there's a big Improving crowd here. If anyone is looking for work, we're a great place to work for. A lot of good people, a lot of curious people, a lot of smart people. So you can see me after if you're interested. I also really like to be involved in the developer community. I'm constantly blown away at the Columbus tech community. I don't know if you've been on Meetup, but there's basically like 3 to 5 meetups almost every night of the week. I have a friend in Buffalo who's a developer, and he went on and they have like 5 meetups every month. So we are really blessed here with the tech meetup culture. 2 that are close to my heart that I help with. One is Condig. We meet 4th Thursdays at ICC in Westerville. And then the Angular meetup group, if you're interested in learning more, we're resurrecting it, another guy, Craig, and myself. And we're hoping to do a mixture of talks and hands-on workshops for people who are interested in honing their Angular skills. So just throw that out there. You can find that on Meetup. So 2 years ago, I was on a project, and it was a large 25 developer project. And Angular 2 had just been released, production ready, 2 falls ago in October. And we decided, you know, it's a client who wants the latest and greatest. We're going to use this. We're going to use Angular and just jump in. So we start building. It's great. We're learning the new framework. And the client wanted us to build a video intake platform. So we were going, our client's client serviced hundreds of clients. So we needed to make a video intake system that was able to be customizable for hundreds of different localized companies. And they, in turn, would have hundreds of different employees with different permissions levels, all this stuff. What this ended up being was dashboard nightmare and permission nightmare. So so many different dashboard screens. You're hitting so many different endpoints to get all the data you need. And so after a while, we started to notice that there would be these bugs that would pop up. You know, it wouldn't pop up right away, but when you're 5 minutes into a dashboard flow, all of a sudden, this isn't working like it was yesterday. And the worst part about these kind of bugs, if you've run into these kind of bugs, is that it was not reproducible. So we knew it was there, right? Knew it was there because it happened every once in a while, but there were so many actions and so many end service calls that we could not really put our finger on where that problem was coming from. And so if anyone's on the 2-week sprint cycle, you know, we had our sprint review with the product owner, with our client, and it was kind of like playing Russian roulette, right? You knew there was a bug out there, and you knew you were going to get it one day, but you just really hoped it didn't come up at that horrible time, which might precipitate an unhappy ending for someone on the team. So luckily we got through it, but there was no systematic way to hunt these bugs down. So my second experience was at another client, and this was a financial institution. We were writing an application to help people open up online checking accounts. So it had a simple user flow, but then they kept layering on the requirements and complexities. And they were using this library, Ngrx. And at first, my eyes glazed over, and I'm like, what are these observables? What are observable streams? I can't deal with this. But pretty soon, there were some advantages that started to come out, just started to emerge. One that I noticed is that even though we were behind schedule, like a lot of projects, and they weren't testing, like a lot of projects, there were a surprising lack of bugs and defects. And if there ever were bugs and defects, it was usually the type where, oh, I forgot to implement X, Y, or Z. It wasn't, oh, this is happening, why is that happening? So there was a clarity to the code because of the Ngrx pattern that I saw that was prone to keeping the bugs out, and then also it was very easy to onboard people. A few of us onboarded into this project 4 months into the project, and very quickly we were able to read the code, know what was going on, know about intentional architectural decisions just from the code base. So the main takeaways from that experience, the main benefits, I would say, like, why am I actually going to go through the pain of learning a new library and using this? These were my main takeaways. The first was it eliminated those race condition bugs. You have a transactional log, because of the Redux pattern, of every state change. So even if something does go wrong, you can deterministically go back through and pinpoint it. Second, kind of piggybacking on that, is that state changes are transactional. And the two things you get out of that are deterministic state reproduction. So again, you can, since all your state changes are transactional, you can reproduce any view you want. Testing is also simplified because of the decision you make with how you update your state. And lastly, for Angular, you can get a more performant app because you can take advantage of the on-push setting. So today what I'd like to do is go through a couple of benefits of modern Angular versus 1.0. RxJS, why that's so important for Angular and for Ngrx. Mostly focus on the Ngrx implementation of the Redux pattern, and then examine each piece so you'll leave at least with those building blocks that you can implement this on an app at home. So the benefits of modern Angular. It's not to be confused with its evil twin, AngularJS. I tell this to people tongue-in-cheek because AngularJS is great for what it was, but I am very surprised. Oftentimes, I find people who have no hands-on experience with modern Angular, and they just think it's the same thing. It's totally different. I think they really should have had a different name for this, because I think if you're presented with a greenfield opportunity and you really do due diligence, and you're looking at what should I use, what tools should I use for this problem, that you really have to give Angular 2 a look. It might not be the solution for your problem, but you should look at it. I also like to think about it, the relationship between Angular 1 and modern Angular, like fraternal twins, right? So identical twins, there's one person and they split and they have the same DNA, they look the same. Well, fraternal twins, they come from the same source, in this case Google, but they have completely different genetic makeup. So that's kind of like Angular 1 and modern Angular. Modern Angular takes advantage of TypeScript. This is something I picked up just from working with Angular. I did not realize how much I liked it until it was gone. I'm working at a client right now that does not have TypeScript. There's so much boilerplate code I have to write just to get some of the things I get out of typings. There's also great bindings for material design. So right out of the box, if it's nothing fancy and you just need something sleek, this is a well-maintained library that plugs right into Angular. It's almost like a modern bootstrap. Also, I've used Firebase with Angular, and there's a great library that makes it so easy to use Firebase. So if you need to get a proof of concept app or even a production-grade app, Firebase is doing some neat things, whether it's authentication or whether it's data or whether it's analytics. There's a lot there that you get without having to build out middleware. And then my last big Angular push is there's this neat library called NativeScript. And it has Angular bindings, so if you ever are tasked with, hey, I need a mobile app, but you have an Angular web app, you can plug in your Angular logic, all your components, and just write views, and you will get a mobile app. I saw a demo, it was like half hour, and it was pretty wild. So that's out there, and another reason why you might consider Angular for your solution. So the second thing, RxJS. What is that, and why are there so many four-letter libraries? RxJS is the JavaScript implementation of ReactiveX. It's just a paradigm of programming. So you hear a lot people talk about imperative paradigms, right, and declarative paradigms. Well, then imperative just means there's more of an emphasis on telling the computer or machine how to do something, and that's what the code is expressive of. A declarative is more, I want to tell the machine, here's the end state I desire, abstract away the implementation details. So ReactiveX is definitely moving things towards the declarative. And the big thing that we get out of that and that modern Angular takes full advantage of is an API called the observable. So an observable stream is almost like, I think about it like a pipe. So instead of a promise, which I think about like a mousetrap, it's like you're setting it for later, and it's going to go off sometime when it's triggered, right? But once it goes off, it's done. In an observable stream, on the other hand, is something you set up the pipeline, and then whenever values are pushed down it, they just trickle down to whoever's subscribing, whoever's listening. And any number of people or observers can subscribe to that stream. They can unsubscribe at any time, and you can, until the end of the world, you can infinitely push down this, or the end of electricity. You can push down these streams. One way I like to think about this is with the visual of a pipe like a nexus of pipes. So in this paradigm, an observable is the stream and the source of the water. Observers are pipes that subscribe and channel the water to the outputs they need to be. So what are some sources? Well, the three main sources, at least in the context of web app development, is user events, server calls, backend server calls, and then system events that might happen, set timeout, or any other async things that you don't know when it's going to come. So the observable API is really good for these kind of things because you can set up a defined pipeline and say, when these happen, I want this, this, and this to happen. So one of the things we'll do is we'll set up a data model that's driven by all these user events, and then we can pipe that back in, and then we can even have our views be listening as observers on that data model. This is a paradigm that will become very familiar the more that you work with modern Angular, especially Ngrx. So Ngrx, again, what's with the four-letter libraries? Can't people be more creative in the naming? I always get them confused. But Ngrx, from their website, the official definition is it's an RxJS powered state management for Angular applications inspired by Redux. And when I first read this, I was like, are you serious? Like, I don't know what these words mean, and I'm definitely too afraid to ask. So just to recap with all the libraries and how does this, there it is. Someone's got to tell me the meme's not there. No. So to recap, how this all fits together in the context of Angular. So we take the Redux pattern, which has nothing to do with Angular, has nothing to do essentially with React. It was invented by a Facebook dev, but again, it has nothing to do. It's not tightly coupled to React in any way. And inspired by that pattern, we use RxJS and then have bindings for Angular, and that's what we get Ngrx out of that. So why Ngrx? Again, what's the value prop? Like, why should we learn another thing? Is this just a fad? Is it going to be passing? Will the repo not be updated in 4 months from now? Well, here's the problem as I see it and why I think this is around to stay. So first, you're building an Angular app, you ng-init, you got your new app going on, you got your component, you're making some back-end server calls, simple enough. You got a little dashboard, maybe you're making a few more calls, then you add another component, making some more calls, you add another component, more requirements, and then you're like, well, there's permissions shared across all these components, right, for people accessing them, so let's have an injected service. So we have some state sharing there. And all of a sudden, though, then there's these other server calls that you're making for verifications, for certification, just any kind of those data things that you need. And then all of a sudden, we have nested components. So we have components displaying on the screen at the same time, and they need to communicate between each other. So now you have localized state, and you have to worry about that getting stale. And then just the army of components comes as requirements, and the years go by. So the problem ends up being is sometimes you have localized state that does not always get reliably updated. So what is the solution? Well, the solution is one-way data flow. And it's amazing with that one architectural commitment, the benefits that we get out of that decision. So here's the Ngrx at a pattern at a 10,000-foot view. So first we got our Angular components. That's where everything happens, all the user interaction happens, right? So say the user adds a to-do on the to-do list. And we fire off what we call an action. So an action is the first building block in this pattern. An action is just a plain JavaScript object. In this case, we give it the type add to do and the payload ski. We're going to go skiing. An action, by definition, at its most simplest, only must have a type. It doesn't need a payload, but you can pass any data you would like in it. The action is then dispatched down an observable stream, which is part of the store API. And then it goes through something we call a reducer, which the reducer is the one place where you may update that slice of state. So in this case, the action is saying, hey, add skiing to my to-do list. So it's going to go through the reducer, and the reducer responsible for the array of values on the to-do list will be updated with this new value. It will update the state. Again, the state is a large JavaScript, plain old JavaScript object, just with nested values to, you might have a UI slice, you might have a data slice, and then within that you might have slices for your views, you might have slices for different backend APIs that you're modeling. And then last but not least, to complete this one-way cycle, this one-way flow, we have selectors. So selectors are kind of like a means of querying the store from your views. And again, this is also an observable stream. So the nice thing is once you set up your selectors, you don't have to do anything. It automatically, anytime any of your state is updated, it emits a value down that observable stream, and your view, because you've set up your pipe work, automatically updates no matter where it is, no matter what time it is. Oh, how does it say? What's missing in this view? Anyone who works on web apps. What is not here? Yeah, so external things. So it's all nice if we kind of trying to eliminate side effects, but how do we get out of our closed system? The way that Ngrx deals with this is a concept called an effect. So an effect would be this object that listens in on the action stream. So again, another benefit of these streams is that we have this action stream that every time an action in our app, anywhere, in any component is shot off, anyone can subscribe to this stream. So this has so many benefits. One is middleware is so easy. So you could stick a logger in there just to listen to every action, and that's what the dev tools will do. But you can stick any kind of middleware right on that action stream and filter out by action type, by the contents of the payload. So you kind of have this really in-depth, intimate look at what's going on with the data stream of your app. So this is where the effects listen in. And so say I want to persist this to the back end, and I fire off an action, persist to the back end, and I have an effect that's listening for that type of action. Then the code in this effect file, in this effect object, would be run. And I can hit a server, I don't have to. I could use them for other things, but hitting a server is one of the most common use cases. And then last but not least, I could dispatch an action. So I could just send an action off, and it goes right back into the action stream. And any effects that I need, any view state updates, that's where those happen. After I post data to the server, and it comes back successfully, I get back the non-stale data, and I put that on the view layer. So there's a strict necessity between the decisions, the architectural decisions, and the benefits that we get from Ngrx and the Redux pattern. The first is there's a single source of truth. We decide that the store is essentially kind of like, you can think about it as a centralized client-side database. I mean, it's in memory, it's just a JavaScript object, but there's a decision that I am not going to persist state in my local components. Also, one-way data flow. So it will always travel around from those 4 components in that way, never the other way. If you do that, you lose the benefits. State is only updated through pure functions, and you'll see why this is important in the future. And those pure functions we call reducers in this paradigm. So it eliminates race conditions because we get this nice transactional log that you could just go through when bugs come up, and you can pinpoint the issue. Deterministic state reproduction. the view renders, and state updates are transactional. Again, testing's easier. So let's jump into and you can pull this onto your computer tonight. This is the official Ngrx demo app. And since we don't have internet, I got a little recording for us, but then we could do some time travel debugging. So we log in. This is a little app that's just going to go query and add some books to my library. Going out, looking for Tale of Two Cities. I need some Old English. Add it to my thing. Go back to the menu. I could see it. I'll be able to see it in my list of books there. Brothers Karamazov. Haven't brushed up on my Russian, so probably should take that out of my library. Don't want to be like a poser with Russian literature. I listened to the audiobook. That's kind of cheating, but so anyway, so that's kind of like this basic app, and it's powered by Ngrx. One thing I do want to show you. See if I can drag. Is there any way I could maybe just show them my screen for a second? Yeah. And then switch it back. I could just, maybe I could drag that over.
Oops. Drag this over.
Yeah. Oh, there we go. Perfect. I just want to show you this because until I used these dev tools, I wasn't convinced about the value. So these are the Redux dev tools that plug in with Ngrx. And something you'll notice here is that you have at the top, you have this list of actions. And these are all the actions. That's that transactional log that I keep talking about. And so you can go back through your app and you can examine each and every one of those. And down here at the bottom, you'll see there's a toggle where going through these actions, you can see the shape of that JavaScript object that is the action. And then you can see the change to your state object that it causes. And then you can even at any moment look at your state object right here. So you can drill in and see the whole shape. You could even copy this out and just work with it in a JSON format. So that's really neat. And you can even debug. So I did this earlier when I had internet. But because this is deterministic state rendering, I can go back, move this over here, and here are, I did like 100 different actions. So you won't see the mouse moving, but you will see all the actions that I took. And so the view, we can go back and generate the view at any state, because every action is defined in a plain old JavaScript action. So the power of that is I can go back to anywhere that I found a bug and found something amiss and pinpoint that. It's also nice because you don't have to restart the app when you're trying to get around a certain flow that might be like 20 actions in. Okay, so now what I want to do is jump into each of these four pieces that at a high level we looked at, but to try to understand what's going on at that low level. So again, the action, it's a plain JavaScript object, nothing scary there. The only required property is type. You need that because that's what distinguishes this action from this action. So in this case, we'll go through the user flow of opening that side nav panel on the demo app. So in this case, we see that's literally what the action is. It's just an object. Now, there are really nice Angular typed bindings for this. And so a very common pattern is that we'll make classes so that we can have constructor functions. So that it's kind of the same idea why we have constants for string literals. So that's what that looks like. Here we have these two actions defined for opening the side nav and closing the side nav. And then we would just new it up like this, where we say new, open side nav, and it would return our object. And we dispatch that from the component in this case. So dispatching an action in different kind of approaches to this pattern, like Flux, there were dispatchers on different components, but in Redux and Ngrx, the dispatcher is a method on the store. So the way you access that is that you inject the store into your Angular component, just like you inject anything else. And then you call it off of your, call dispatch off your store object, and you put in whatever action that you want to dispatch. And that's how that looks like with the binding in your template file. Just open side nav. So once you dispatch that, once the user does that action, the action's fired off down the action stream, and then it comes to the reducer. So the reducer, so it's a pure function. And all that means is that there are no side effects. So whatever comes in, if it has the same inputs, the same output can be expected. And one of the reasons this is important for Ngrx is because that agreement that we only update state through the reducer and we do not mutate it. So we don't change properties on it. If we're ever going to update, say my slice of state is an object with 8 properties, I'm always going to replace it with a totally new object. What that's going to do is that will force the variable that points to it to have a new reference to that new object. And there's several benefits that come from this, even aside from like data integrity. Each slice of our state has a different corresponding reducer. So we saw one just for the side nav UI, but a common pattern is that for each UI view, you would have state that tells about all the toggles and all the different settings, but then also you would have slices of state that would model backend API calls, what you expect from those, and you can really organize them around the use case of your app. So the reducer would look like this. Usually our reducers too would be in folders around the component. So that's one thing I like about Ngrx, that it encourages you to manage, even though your state is in a large state tree that's centralized to the whole app, the way that you usually organize it is at the local level. So if I had a component where the user logs in, the reducer for that login page is actually going to live in the folder near there. So it's very readable from an app maintainability standpoint, even though that gets injected onto the state tree. So this is what a reducer for this layout state would look like. So at the top you see we're passing in 2 things. We always pass in the initial state, or this that we can define. You see us defining the initial state if there is not one set. And then we pass in the action. So that would be the possible updated state. Every reducer typically has a switch statement, and you switch upon the action. In this case, we have 2 actions. We have, is the side nav being closed? Is it being open? And depending on which action goes through the reducer, we're going to return a whole new object with show side nav true or false. And otherwise, the default for a reducer is always, always, always to return the state. Because if you just return the state that you passed in, the default state, the reference does not change. No new value will be emitted down your pipeline of observable streams. And in each reducer file, we also use TypeScript to really define the shape of that state. So this is where, when you saw the state tree in the dev tools with all the different properties on it, this is where that comes from. So in each reducer, we can define, how do I want this state to look? And so the convention is that you have your initial state defined here. In this case, we have it false because we want the default for the side nav to be closed. And this is just the view of the state, the overall state from the dev tools. It's a godsend of a tool. If you ever need to jump into an app real fast and figure out what's going on, I've found jumping into apps now without this, it's a nightmare. It's like, where are they saving this? Where are they persisting that? This really, a lot of benefits from that centralized pattern. Okay, so now we're at the point where we have our updated state, but now how are we going to get that rendered to our view? So how are we going to know to toggle that side nav open? Well, we set up a selector. And the way to think about a selector is basically just a callback function that we subscribe to to that slice of state. So we're going to subscribe this callback function to say, I want you to toggle this open when this Boolean in the state is flipped. Really nice thing about selectors is they're composable. So you can combine them to, so imagine you have a state tree in a large app, and you probably have, maybe you have like 20 properties at that first level. And then under that, maybe you have thousands deeply nested. These selectors allow you to really be precise, and you don't have to do that dot notation to go really deep, and you don't have to worry about null pointer errors, because this is a library that takes care of the safety checks on those. It's also memomized. I always hate this word. But the neat thing about this is, so these queries cache values. So say that you ask for this really complex query of your state tree. You want to get this deeply nested piece and this other deeply nested piece and a third deeply nested piece, and then put it together in a nice object for your view. So essentially, it's a way of making view models. If you do that the first time, and then you reach for that 2 minutes from now, if those 3 elements have not changed on your state tree, if those reducers don't have new references, you'll just get the old cache value. But if any of those references change, it knows to query that and to calculate it. So selectors are lazy in that way, and it helps speed up your app. So this is how it relates to the store state. So think about, here's our store state for this app. We got layout, we got router, we got authorization, we got books. So our first selector here, we're going to just take the layout. So they provide us with this function, create feature selector, and that allows us just to get that parent level feature selector, in this case layout. And then I'm going to pass that get layout state, and this is what I mean by composable. We're going to pass that into the create selector function, and then I can filter off of that however I want. And the neat thing again is I can have some of these selectors live in data-driven areas of my folder structure of my app, and then ones that are particular to views and view models, I can have them live in those component folders, yet I could still use in one centralized place these like parent selectors. And so here's where we actually use the selector in our component. So going back to the app component, the actual Angular component, how do we actually use these selectors to set up that pipeline, that observable pipeline to say, hey, when this changes, I want you to update the view. So you see there you inject the store, and there is a method on the store called pipe, and you pass your selector in with select, and that is that initial setup of that pipeline. So it sets it up, and whenever new values are emitted on that slice of the state, your view will be updated. But there's still one more thing, because if you see the little cache money signs at the end of my variables, the show side nav and the logged in. So what it returns, if you think about how Angular does service calls, right? It returns them observable. So you can't just use that because it's wrapped. So you got to unwrap that and you got to subscribe. So the typical way to do that is with the async pipe in Angular. That kind of is the out-of-the-box solution. I've also seen people write their own libraries to subscribe and unsubscribe, so you don't have to do that boilerplate code. But this is the most conventional pattern. And then last but not least, we have the effect. So how do we deal with those service calls? So here we see this is that call. So when I type in, search for a book, want to find a book to add to my library, this is the effect that describes that call to the server. So let's walk through this. So first we have, it's annotated with the add effect, and that's how it's registered, and it knows that it's listening to that observable stream. Next we have down here, you pass in what you're listening for, the type of action. So we in this effect are listening for only search actions. So this will only execute when search actions happen. RxJS has a great library of functions to like modify streams and oh man, Leonardo can't even get back. So it actually saves you from callback hell. These operators help you to really to reason about your app in a logical and a flat way. So you'll see that we're doing a lot of manipulation, but you get a nice readable human language down the page. So to bounce time, what are we doing here? We're saying, I don't want you to send a search every key up, right? Because that'd be insane. I want you to wait for 300 milliseconds in this case. And then I'm going to look into that, and if it's an empty string, I'm returning empty, which means if there's an empty string at any point, they type in something and the user backspaces, I don't want you to send a search. And then also, they've added a Leonardo, get in the box. They've also added, there's an interesting manipulation at the end where they say that we want to cancel, so say the user's typing and every 300 milliseconds they're sending calls to the server. Well, what happens if the user's like not fast or not thoughtful and like they're just typing different things? You have all these calls out. Do you want them to all return? No. You want to cancel them if one call comes back first. So that's what they're doing down here. They're saying, take this until the next one, if the next one returns, just cancel it. So one of the things that I've really enjoyed about working with effects is that you avoid that pyramid code. You avoid callback hell where you're like looking in all these files or all these places to just understand what are you really trying to logically get at? Like, what is my end goal here? This is a real example with modified names to protect the innocent. But on the second app that I was working on, we had this end call before you would open an account. And we had to hit like 10 different microservices to make sure that this person's not a gangster, that this person doesn't have a criminal record, that they qualify for this reward, all these things. And it had to happen in that order, and subsequent calls could not be fired off until this one returned and it was good. And we needed to control for error handling at every point. So what you see, there's these 10 lines represent 10 different service calls. And so we were able to model that very nice. And what I don't show you is the implementation detail of all the error handling into those what those functions call into. But I just want to highlight that concat operator. So what the concat operator is a good gateway drug into the RxJS library because it's pretty straightforward. There's a great website that you should definitely check out called RX Marbles. And it helps you to get into this reactive stream paradigm because it is a very different way of thinking than this imperative way. So in concat, what happens, every observable stream that you put into this concat operator, so in this case we have 2 observable streams with 3 events on the first one before it ends, and then these 2 events on the second. What concat will do is it will combine these observable streams. It says, whatever you put through that first observable stream, take that and put it in the result, and then when that stream is cut off, move on to the next one. So looping back to our gigantic 10 endpoint call, what this is doing, since we have that nested in that concat call, it's saying complete everything in the observable stream, and only when that one stream is done, then proceed to the next, then the next, then the next. And within each of those streams, we can have error handling for whatever we need the app to do in those cases. And I find this extremely more readable than other options when dealing with complex calls like this. So one of the advantages I wanted to dive into a little more deeper on the Angular side of things, I mentioned that we get a more performant Angular change detection. Why is this? Well, there's something you can set called onPush. It's a change detection strategy in the metadata of your component. So you just set it like this on your component, and then say we have a squirrel data type. So our squirrel's got a tail that's bushy, color red-brown, age is 2. Its energy level is insane. Its favorite food is pizza. I went to the University of Dayton, and I kid you not, squirrels would jump out of the trash can with a whole piece of pizza in their mouth. It was it was physically impossible, but it happened. So this is in your component here. One way of updating this, but not the Ngrx way, is by mutating the state. Is that you would change the age property and energy level like that. But that's not the way to go about this. Would violate our Angular in onPush would not know that a change had happened because in its traditional form, Angular walks down every property, and so it's always listening to every property. So in its out-of-box form, Angular would know that, hey, you've changed the age of the squirrel and you've changed the energy level. However, when you set the change detection strategy to be on push, what that is saying is don't look at the individual properties, so it doesn't have to do all that work of digging into every nested property on your components. All I want you to do is to look and see if the variable reference has changed to a different object. And so when you tell Angular that by setting that on push strategy, you're making an agreement whenever I am going to make a change to state. Instead, so say I want to change the age and energy level, well then the appropriate way to do that would be to fire off an action with a new squirrel object and just update the two that I want. And so the performance gain could be an order of magnitude depending on how many properties and nested properties you have, because now all that it has to listen to is all of your reducer slices of state instead of every property and every component at all times. Usually it's not a problem, but on an enterprise level app where you start to scale, it could be where you need to go for that performance gain. And then before I wrap up, I just want to put this out there because this was a tool that I have found very helpful. There is a consulting group called Narwhal, and they put out a tool called Ngrx because it's 2 letters instead of 4. But they were 2 the authors from Angular. One of them authored, main author on Angular 1, and one is an author on Angular, modern Angular. And they put out this tool. If you've used the CLI, anyone use the CLI before? Yeah, CLI is great. Like, I love it because you can just pop up an app so fast. So this brings 2 benefits. One is it's a CLI for Ngrx. So they give you CLI type commands to just get the boilerplate out of the way so you don't have to do all that. And it also gives you Angular workspaces. So instead of like, you know, if you knew up all these Angular projects, all of a sudden like that's big because there's a lot of boilerplate just for Angular. So it will allow you in this sandbox to have all your projects and then just have common shared Angular files that are like your node module files. So it makes development nicer. So why should we not be like this guy? Maybe we should. Maybe Friday pizza night would get exciting. Maybe he just got the saw and he wanted to. This is my culinary artistry. No, but seriously, the question I want to leave you with is why should we use this? And I think this is an important question as engineers and as people that work on teams, and we're trying to deliver value to our clients and to our end users. And so it's not always the best to use the newest tool and the newest thing. So I really think we should ask questions about why and when does this tool or this technology fit. So those questions I would ask, or those things I would ask would be, does my project have user workflows that are complex? Are they not just a simple one-page admin dashboard? Does my app have a large variety of workflows? Maybe you have a ton of different permission level, admin, first sergeant, second sergeant, all these just different levels. Users, do they collaborate? If they're collaborating in real time, like a Facebook-y kind of thing or a chat, again, you're going to run into issues of how do I keep state updated real time? And Ngrx with RxJS will be very helpful. If you're using WebSockets or server-sent events, that's where like these reactive libraries shine because you can really model those things and set up those pipelines and not even worry about it after you do that because your views will update. And if you're loading data from multiple endpoints, again, it's going to give you that transactional log that has saved my butt so many times when I'm debugging. So that's all I have. I want to have some time for questions and answers, but I just want to say stay in touch. I enjoy connecting with different people, exchanging ideas, problems, all of that. You can get me at Twitter, at GitHub. Tonight I'll post these slides, and I'll also post, I have a list of like 20 links that if you're just getting to Ngrx, this is where you should go, and some of the best articles I've read. And then also, yeah, if you need help on a project or something, feel free to reach out. But thanks so much for your attention, and thanks for coming. I'll take some time for questions if you have any. Sure.
Any chance you can, when you were showing the timeline thing and you could go through, is there any chance that people can export that so they can send it to people in case they want to show them something?
The question was, looking at the dev tools where we were hopping through the list of actions, can you export that? I haven't done that, but I would be surprised if you couldn't, because I know I copy out the state all the time, and there's a raw view. I don't see why they wouldn't have that, but. Have any downsides? Yeah, so that's a good question. What are the downsides? I should have that slide. So the downsides, I would say, are there is a barrier to entry. Like there is like a month, or at least I was like dazed and confused for a month. It's like, I didn't even have any wine or anything. Because it really, I think the biggest paradigm shift is to that reactive functional programming, even more than Ngrx. I also think if you're on a team and you're deciding to go this way, you do need buy-in. So if you have some stubborn people and it's not like we're doing this, that could be a reason for not using it. We got another question. Would you say an accurate summary of RxJS is that it's just a more formal set of patterns on top of promise chains? So I would say no, that's not the case. From my understanding, it's a whole different way of handling asynchronous things than promises. It doesn't actually use promises, so it's not like a library that sits on top of promises and then manipulates it and gives you a different experience. It's a fundamentally different technology. And if you want to understand it, there's actually been some good work. It's been so popular. Netflix uses RxJS extensively. But Ben Lesh is the curator of that library, and there's actually an open JavaScript thing to get it into the next round of JavaScript. So I would say check that out because that would actually get into the innards of how it's implemented and how it's different. The two things I would highlight that is different than promises fundamentally, one is that you can push an infinite amount of values down it. So you set up the stream, and it's there. You can just push values until you push down the end signal. The other thing is it's actually really 3 streams hidden in one. There's a value stream. That's what most people use, and you emit values down as many as you want. There's an end stream. You only use that once. You emit it, and then stream closes. It's done. And then the third is the error stream. So if you emit a value, and for whatever reason something goes wrong, you can put a callback in there to handle that error. So good question. Yeah, the question is, how do you handle large data sets? Yeah, so that's what I would do, is put it in the store and have like a distinction for your data versus your UI view things. Now, I mean, one thing, just like any application, you have to keep in mind is the size of that, and you might have to flush it. So with those selectors, remember I was talking about the selectors? Say that selector hits a big and returns a big data set. There's a way that you can force it to dump its cache so that you don't end up with these selectors, because that could run into a memory issue. Other than that, you might, depending on how big the data set is, but I don't think that's a limitation of this setup necessarily. It would just be a limitation of client-side apps, is that you just have to go to the back end again, depending on what you're doing. So. Right, so the question was, are there any issues communicating between client applications if they are Rx applications? And can you sketch that out like?
So something more like data channels using web streams, so like literal client-to-client, you mix the bulletin server, then there's a direct connection out to it.
That is a great question. I have no idea. So if you find out and you want to post in the green Slack channel, it would be greatly appreciated. The question again was about client-to-client direct communications. I'm not sure about that and the implications. But my guess would be that it could handle it because the way you set up the pipelines, it's agnostic to the source of that asynchronous event. So from an Rx standpoint, it doesn't know and it doesn't matter that the source of that emitted event is a user thing, a client-side system thing, a server call. So I would guess that the work to be done would be that first setup of how do you set up the client communication to emit an observable, but the pipelining would be much the same, I would guess. Anything else? This is like blinding. I'm amazed I stayed in this box too. I usually like to walk around, but. Thanks. Thanks so much.